You're listening to the Check 6 podcast, brought to you by editors from across the Aviation Week network. Listeners now have access to special subscription offers, including 30% off Aviation Week and Space Technology. Go to podcast.aviationweek.com to learn more.
Hi, and welcome to Check 6, Aviation Week's podcast. This week, we have something special, an interview by space editor Irene Klotz with Elon Musk, the CEO and chief engineer at SpaceX. Irene talked to Elon, who founded the company 18 years ago to develop technologies for people to explore space and settle Mars. NASA's upcoming commercial crew Demo 2 mission will be SpaceX's first launch with people. Elon talks not just about that, but also about the development of Starship, a fully reusable super heavy lift launch vehicle, the riskiest part of the Demo 2 mission, and what's happening with SpaceX's Starlink internet service project. Over to you, Irene.
It's been an awfully long time coming. I think.
Yes.
Oh, what?
In fact, I'm a bit worried about it because, man, it took 18 years. Well, and we haven't succeeded yet, obviously. Don't want to jinx it or anything. But we better accelerate progress, or if it's, it's taken 18 years to get to at least be ready to take people to orbit. And we're going to have a base on the moon, like a proper base, where, that's, permanently occupied and get people to Mars. Well, we better improve our rate of progress a lot, or, in order for it to happen before, like, let's say we're dead.
Yeah. Basically, yeah. When you said that at the satellite show, it was like, well, that's an unvarnished truth.
Yes.
So in hindsight, if you were doing this all over again, is there anything that you see that you could have done to make this path shorter?
Well, hindsight's always 20/20, and there are a lot of design decisions that I think would have made differently, or I would sort of just gone probably different paths. Things do get a little set in their ways, though. It's like the architecture that Dragon uses, which is kind of a blunt body re-entry with hypergolic propellants, and side mounted thrusters is sort of it made sense at the time, but because you just didn't have any clue of what exactly is a system that would look, what would a system look like that is able to create a base on the moon and a city on Mars. Starship is kind of that thing. I guess if I could go back in time, I would probably not use hypergolic propellants, just because they're very expensive and difficult to handle, and wouldn't use a blunt body re-entry vehicle. These are all design decisions that work for and work fairly well for Earth orbit stuff, but are not well suited for going to the moon and back or going to Mars. They're not from the standpoint of like having a full base or a city on Mars. You could like do a limited effort there. I don't want to. It's sort of like if I could go back, I guess I would do more of the Starship stuff.
So you don't think that this the low Earth orbit is not a necessary stepping stone?
In a way, it's a necessary stepping stone in that we did not know what was needed to go beyond until trying to go to low Earth orbit. And Dragon could be used to loop around the moon there is a lunar architecture that where you could use Dragon, and Dragon could be used to land a limited amount of cargo on Mars. But I guess at the time it seemed like a good idea, and it seemed like a straightforward enhancement of the Dragon 1. And it ended up it's been much harder than expected.
You and Gwen and Hans have been very gracious in your acknowledgement of NASA's support for SpaceX, not only in the development, early development fundings and a good customer, but later on, did having NASA as a partner in the development, do you think it helped you or slowed you up or speeded things up or slowed things down?
Well, I suppose both, in that we wouldn't be here without the prior work of NASA, as the saying goes, standing on the shoulders of giants, and we. There's just this. It's a hard problem, and and I don't think we would have gotten this far without NASA's help. That's for sure. So going now that there's the on the other side, there's like NASA definitely wants to, once a system is working, there's a tendency to want to keep using that same system.
Yeah.
So I think it will require we're gonna push for obviously a next generation system, which NASA is also supporting, I should say, of course, with this Starship to the moon and that kind of thing. I certainly would like, for sure, just to be clear, say I'm super grateful for the support of NASA, and we definitely would not be where we are without that. And in fact, this is fundamentally a NASA mission that we are supporting here. So, and then I think, NASA would probably be, would probably acknowledge also that we do need to push in order to take things to the next level architecturally. So I think it's great. There's I'm trying to figure out a good way to say this, which is like we definitely wouldn't. We would only be here. We're only doing this because of NASA. I mean, there's no way we could have done this without NASA. So,
what kind of market do you think there's going to be for commercial orbital transportation outside of NASA?
For people.
Yep, for people.
I guess we'll find out. There does seem to be. Well, I guess it depends on how much it costs. Obviously, a number of people have been up on the Soyuz, the space station, and I think we'll see some number of people every year that want to do that. I don't actually know what the market is, but I don't know. It might be a few $100 million, perhaps. This is just a guess. So, yeah, I think
Do you think?
I wouldn't say that there's a big market, depending on what you consider big, for Dragon, because of the cost is too high. But once we're able to make Starship fly, then I think we could improve the costs by a great deal, by like an order of magnitude or more. And we couldn't have gotten to Starship without really going through the Dragon path.
So Elon, do you think, are you thinking about taking a ride on a Crew Dragon?
I'm not actually thinking about that. I think probably not, because I need to focus on advancing Starship. The goal of SpaceX has always been to create the technology necessary to extend life beyond Earth. Make us a spacefaring civilization, and a multi-planet species. So it's not really from the standpoint of like, say, my personal enjoyment of going to orbit, which I certainly would enjoy, but it would take up a lot of time, and then I would not be able to work on Starship. So, and then I have Tesla obligations as well. So, I certainly would like to go at some point to the moon or Mars, and I need to make sure that we're on a good path to enabling humanity to become a spacefaring civilization and a multi-planet species. So that's what's really important.
You told me a long time ago, one of our very first times we spoke, about that you felt that there was a very small window of opportunity when there was enough private capital or capital in private hands, basically from the wealth of the internet and the technology and kind of a governmental regime that was tolerant to do this. Do you still feel that way? Do you think that there's the window's opening, or is it narrowing, or what are the limitations of creating this future that you've been talking about and working so hard for all these years?
Well, there does seem to be quite a lot of capital flowing into rocket startups these days. I was quite surprised. I think there seem to be a few dozen rocket companies. A lot of it funded ex-internet, but not all of it. So, I mean, hopefully we are at the beginning of the dawn of a new era of space exploration, where there are many rockets that are capable of taking people and extending consciousness in general beyond Earth and life as we know it beyond Earth. The one thing that I think is just a very important thing for these rocket startups to be doing is reusability. So I don't see enough emphasis on reusable rockets. You simply cannot make the economic work without reusability. Just as for aircraft or cars, if they were not reusable, almost no one would use them, or they would be too expensive. Or if you had to fly a new plane every time you flew, almost no one would fly.
So do you think that should be like written into a requirement, even though, not for the sake of delivering national security space payloads into orbit, but as part of a overall technology advancement? I mean, that, there's a big difference.
Actually, yes. I think we need to close the loop on, on cost per ton to orbit, and say, okay, we need to dramatically improve our cost per ton to orbit, like by 1,000% or more. I'd say 1,000% from where Falcon 9 is on a marginal cost basis, which, excluding overhead, might be around, overhead R&D and whatever. In best case scenario, Falcon 9 is probably about $15 million for 15 tons. $1 million a ton. And then we really need to be under $100,000 a ton, if not closer to, $10,000 or $20,000 a ton. And these are crazy numbers by normal space standards.
Yeah.
But they're what's needed in order to have a continuously operating significant base on the moon and certainly a city on Mars. The current rocket costs would make it impossible for even if all of Earth was really dedicated to making a city on Mars, the cost of creating a city on Mars would be so high that we wouldn't really be able to afford it. So it's like basically we need to improve things from where Falcon 9 is by, like I said, somewhere between 1,000 and 10,000%. Falcon 9 is the lowest cost per ton in the world by far.
Do you think that Starship's going to have to go through many iterations to get to that point, or is the design that you're already kind of building and testing take care of these economics?
I think this architecture, assuming it works, which I think it does from a physics standpoint, it does achieve the 1,000% plus improvement over Falcon 9. Because essentially it's assuming that it is fully and rapidly reusable. So I should say that there are important qualifications on reusability. Reusability must be complete and rapid. So with the shuttle, you had partial reusability, and it was definitely not rapid. So then that didn't ultimately improve the cost per ton to orbit. In fact, the shuttle had a higher cost per ton to orbit than Saturn V, which was fully expendable. I believe Starship can get there. The full reusability is critical. So, because with Falcon 9, of that $15 million marginal cost basis, the upper stage is about $10 million of that. So, and then the difficulty of recovering the fairing and the booster from out to sea add cost to the operations, and using helium as a pressurant and using rocket propellant grade kerosene also adds the cost. And this still, call it $1 million worth of refurbishment needed for the booster. So with Starship, it should avoid all of these issues. Just fully reusable, low cost propellant, autogenously pressurized with gaseous oxygen, gaseous methane, so no helium. And there is no cheaper fuel than liquid methane. And the OF ratio of Starship is like roughly 3.5. So meaning there's 3.5 tons of oxygen for every ton of fuel. Mm-hmm. Whereas for Falcon it's 2.5 roughly. And oxygen is much cheaper and denser than the fuel. So you actually want a high OF ratio. Like the cost of oxygen is just basically the cost of electricity. So you can create the oxygen just with very low cost, like wind power, for example, in Texas, where especially when they're generating excess power, you can get power for like 2 cents kilowatt hour or less. So, and at roughly 3.5, maybe 3.6 OF ratio, you're around a 78% propellant mass, oxygen versus fuel. So, having a full reusable system with low cost propellant, predominantly oxygen, is absolutely the right way to go from an architecture standpoint. I'm not aware of an architecture that would be better than this, that does not violate some law of physics.
How's the progress for getting to a hop flight with the SN4 vehicle?
I think we're making good progress. I have redirected SpaceX's priorities to be very focused on the crew launch. So that's going to slow things down on the Starship run for, until we have a successful launch. So I'd ask everyone just to be extremely focused on ensuring that that the astronauts are safe, but obviously the right thing to do. So we're gonna that's slows things down a little bit. But if the launch is successful, I don't take anything for granted. But if the launch is successful, then we will redirect our energy towards Starship. As a rough guess, I think we're probably a few weeks away from a hop. So we're pretty close. And then the Starship production system is being built. So that's harder than the rocket itself. So I think, like, some people don't sort of quite understand, like, where the true difficulty is. I think at this point, designing an orbital rocket, I would say, is pretty easy. I mean, I don't know if you realize it, but there's a lot of people that can do it. You can literally read the books on the internet, and it's all the information you need is just available to make an orbital rocket, to design an orbital rocket, I should say. Now, to make it, that's like a whole order of magnitude or more difficulty to make even one. But then to make the production system, that's at least an order of magnitude greater than making one. And people often think, like, well, once you've made one, can't you just easily make a whole bunch? Definitely not. It is 1,000% harder to make the production system. And then you've got to figure out how to have a really efficient launch system so that each launch is not a big deal. You need to make space flight like air flight, where it's not considered a big deal to fly a plane several times a day. It needs to be the same for rockets. But refining that whole flight process is also very difficult. The early jets, I think they had, an hour of maintenance time for every minute of flight, or worse. So you fly for 10 minutes, you have 10 hours of maintenance. Then they got it to the point where you could have 1,000 hours of flight before you needed any maintenance. So there's no maintenance between flights. That's what we need for rockets. We need to make rocket flight like air flight.
Elon, you mentioned that you paused Starship development, and of course the Starlink launch out at the Cape was also rescheduled for after Crew Dragon. What's the vibe like with having people flying rather than cargo? Does it what's different?
Well, the stakes are much higher, of course. Whereas you can always rebuild a satellite. If we've lost life, there's no rebuilding that. So we've gone to extreme lengths to review safety standard. It's just the design of the rocket, the manufacture of the rocket. We've turned over every stone so many times I've lost count. And NASA's been an integral part of those reviews. We've had multiple outside agencies like the Aerospace Safety Advisory Panel and others also review things. So it's a level of scrutiny that is much higher than for a satellite mission. Yeah, and so we are continuing to make some progress on Starship. It's just that the emphasis is very much on a safe crew flight.
What part of the Crew Dragon system or the Demo 2 mission in all do you think is the riskiest? And I guess from an engineer's perspective.
I guess the part that I would worry most about would be reentry, which won't happen hopefully for a few months from now. So with Dragon 1, we have a simple conic on the leeward side of the back shell, essentially, of the spacecraft. So it's really quite symmetrical, no protuberances or anything. Whereas with Crew Dragon, because we've got the escape thrusters that are side mounted into the back shell, that creates an asymmetry. So if you rotate too much, then you could potentially catch the plasma in the in the Super Draco escape thruster pods. You could potentially cause either a control disturbance, or you could potentially overheat things. You just asked, like, what is my biggest concern? So
right.
We've looked at this 6 ways to Sunday, so it's not like I think that this will fail. It's just I worry a bit about the fact that it is asymmetric on the back shell. And you could have like a strange sort of roll coupling on as you try to come in if you turn too much. Now, like I said, I think this is a lower. I think this is a lower risk, but that's just what I would put as my biggest concern.
What controls the orientation of Dragon during reentry? Is that something that is any what keeps that oriented in the right direction so that doesn't happen?
Well, the center of gravity needs to be in a precise location so that it's pretty tight. It's basically within a few inches, ideally within 1 inch. You prefer it to be within like a few centimeters, basically precision. So the center of gravity or center of mass, if that is in the right place, then everything should be fine. If we load it incorrectly somehow, then and the center of mass is in the wrong place, that could be a problem. Overall, we've scrutinized this so much that, like, it's not as though I think any of these things will go wrong.
Mm-hmm.
I probably, the thing that would go wrong is something that we never even thought was an issue. If there's a risk, it's the unknown.
Yeah.
So what have we not considered? I think we obviously want to make sure that there's not any cross-coupling between the launch escape system and the on-orbit maneuvering system, like any kind of like negative interaction between the two.
Yeah.
Because one's a high-pressure system and the other is a low-pressure system. So if you don't want to send high-pressure helium at 10,000 psi into the low-pressure system, that could be a problem. But there are a lot of good things about Dragon. I think one thing that perhaps it doesn't get quite enough attention is that this will be the first time that there's an escape system all the way to orbit.
Mm-hmm.
And the escape system does not need to be jettisoned in order to have a successful flight. So for Soyuz and Apollo, they had a solid rocket motor tractor on the nose, and it was too heavy to take all the way to orbit. So basically, only had escape capability for the initial portion, like maybe the first third of the flight or thereabouts. It was generally the riskiest portion of the flight, but you didn't have escape capability from the upper stage. essentially.
Yeah.
So whereas Dragon has escape capability from all the way to orbit, and you do not need to jettison something from the nose. Like if Apollo or Soyuz failed to jettison the solid rocket motor, it's 100% chance of the crew is definitely going to die.
Yeah.
So getting rid of that state change is important, and having escape capability all the way to orbit is great. That's quite a big safety improvement, I think, relative to prior architectures.
I found it interesting that in getting to your the design requirements for the loss of crew, loss of mission numbers, that launch is now no longer the big risk. Not even the second biggest risk. It's the MMOD and the parachutes, and that really does change the dynamics a lot from the perspective of what we've had the past 50 years watching people fly on rockets.
Yeah, absolutely. Because it's essentially the same rocket flying satellites and flying Dragon. And we've now, actually, I'm not sure of the exact count, but I'd actually have to look it up on Wikipedia. But we've had a lot of flights of Falcon 9. And we must be past 60 at this point. Quite a few.
Oh, you're up about, I think you're at 87.
87, okay, wow.
Yeah. Yeah, you've been really busy these 18 years. I know you're...
Even if this architecture is, I think we must have flown on the order of a dozen times of Block 5. We must be close to that, close to 10 for the Block 5 Falcon 9.
Yeah. If you have another minute or so, I wanted to just ask you briefly about Starlink. You made a very prescient statement at the satellite show about the goal is to not go bankrupt, and of course, over the last couple months,
really difficult.
Well, OneWeb and Intelsat are all, logged in at Chapter 11 now. So what is it that you can do differently to avoid losing money and having to bail out of this whole project? And what's been the kind of the long pole in the tent from the technology? Is it the setting up the consumer services, or is it still the antennas? Or obviously you've got the launches down pat, and it seems like satellite production has been going really well.
Yeah, overall things are going pretty well with Starlink. The satellites are working. We've a good satellite architecture. We've got a great engineering team. But I think the secret to SpaceX's success is that we've got the best. We've got a better engineering team than I think has ever existed. Working on Starlink, it's just very extremely good. So the satellites are working. We've got a vehicle which is mostly reusable, 80% reusable, and so our marginal cost of launch is much lower than it's been ever in the past. It's $1 million a ton. That's pretty low. So I think the biggest challenge will be with the user terminal and getting the user terminal cost to be affordable. That will take us a few years to really solve that. And the user terminal cost is as considering like the fully installed cost. So but the hardware as well as everything required to get it set up and running and running reliably for a decade or certainly at least 5 years plus. You can't send people out to service these things because a lot of places will be in the middle of nowhere, so it's the fully considered cost of the user terminal will be the hottest challenge for Starlink or any space-based communication system that is meant for the general public. So, we're gonna, I think, roll out a lot of these things. I think we've got a strategy where success is one of the possible outcomes.
That's really funny. Well, thanks, Elon.
Yes.
Good luck.
That's high praise, because I think there's been a lot of them where success was not one of the possible outcomes.
Yeah.
So I think we're at least, it's one of them. And I think I feel pretty good about it. I feel like fate wants this to happen.
Yeah. How are you feeling about launch on Wednesday? Weather and everything looking good, or is it going to be pretty tight with that 1 second launch window?
That is pretty tight. We are used to a tight launch window when trying to rendezvous with the space station.
Yeah.
But we do have a lot of other constraints. Basically, it's weather along the ground track path in case there's an abort. Yeah. That's the biggest risk, I think, to not launching on Wednesday, is if there's bad weather along the ground track path, and in case we need to do an abort. So far it's looking good, I think, but that would be the risk.
Okay. It was pretty exciting to watch them run out to the pad today and go through the countdown prep. It's certainly not the shuttle program with those Teslas running around out there.
No, it's super exciting to see this happen. It's a culmination of 18 years, and I never thought it would happen. In fact, Irene, I have a frame on near my desk for an Aviation Week cover story long ago that was titled "Can Tiny SpaceX Rock Boeing?" Do you remember that?
I wasn't with AvWeek then. I was with Reuters, but we have 104 years of archives, and we'll get you another plaque for next week, because it'll be on the cover again.
It sounds good. Well, the things when AvWeek did it's kind of a comical photo, to be frank, because I think the implied answer is no.
Yeah. Like.
And you look at the picture and it's like, okay, we look like a kid who just first day at elementary school or something,
Yeah.
Doesn't know quite where to go.
Yeah. In doing a lot of research, I saw a lot of video clips and stuff of you from 2000 and around then, and you're such a kid.
No, I'm no longer a spring chicken. My goodness.
Well, no, it's a really huge accomplishment, and 18 years really only seems long, but when it's measured against a human lifetime, it's one thing I've learned in this program. I've been covering the space program since '87, is that everything feels like you measure your whole life by these programs. Like Hubble's going to be over, ISS, and your kids grow up, and
yeah, totally true.
It's really amazing, but it's really fun, and things are they always kind of take a twist and a turn, and this next step that's starting is something that really NASA's been talking about since the shuttle. You remember the first shuttle missions were they were flying teachers and politicians and all the national security payloads. So this idea of having space be a place that you can go has been around forever, and it's been a very slow progress, to get here. But you know what? 100 years from now, it'll be like, there'll be no gap. It'll be like this, and then this happened, and then we were on Mars.
I sure hope so. That would be great.
Yeah.
If I knew we were going to have a city on Mars, and I would die happy for sure. If humanity was going to be a multi-planet species, and just so the consciousness would be out there among the stars. I'd be a happy person, that's for sure.
Yeah. Well, no one will ever say that you didn't try, Elon.
I'll do my best.
Thanks a lot. Good luck.
All right, thanks, Irene. All right, bye.
Bye.
Thanks for listening to another edition of Check 6, which you can download on iTunes. If you've been enjoying these podcasts, please leave us a positive review. Tune in again next week for another edition of Check 6.